Let us now talk about binary tree. In binary tree, every node has at most 2 children, or we can say degree of every node is at most 2. So degree of a node can be 0, 1 or 2. In other words, a node can have 0 child, 1 child or 2 children. Here is an example of binary tree. 30 has 2 children, 40 has 1 child, 50 has 2 children, and these nodes do not have any child. This is how we actually represent a binary tree. We have a root node which is representative of this binary tree, and every node has 3 fields. It has this field called key or data, and the 2 fields are references or pointers to the 2 children, at most 2 children, right? So this field is called left child pointer or left child reference. When we talk about programming languages like C and C++, we call them left pointer. But when we talk about languages like Java and Python, we call them left reference. And the right child and right reference. So every node has 3 fields. This is simple representation, and this representation shows more of implementation details. This particular node has only one left child, and this child is represented as null. Small letters in Java and capital letter null in C and C++. So I've written small letters here, but if you are C++ programmer, you can consider capital letter null. This has both the children, so one pointer or reference points to or refers to the left child, and other points to or refers to the other child. And since we have 2 children at most, we call the left side child as left child and right side child as right child. For leaves, both left and right are always null. So this is how it's internally represented in memory. Please note that this representation is the most common representation of binary trees, but there are other representations as well. There is array representation also possible for binary tree, and we do have some trees which are typically represented as arrays. For example, binary heap, segment tree. When we talk about them, we see that we can efficiently represent them as arrays. But in general, when we talk about binary tree or binary search tree, which we are going to study later, they are typically represented using this linked structure, where we have pointers and references linking to the children. Now the question arises, why do we study binary tree only? Why not general n-array tree, where a node can have any number of children? The reason is the most popular tree data structures which are used a lot are based on binary tree. Binary search tree is the most used tree data structure, and binary search tree is a binary tree variation. Binary heap is also a popular tree data structure which is used to represent priority queues, and binary heap is also a binary tree data structure. Segment tree data structure, which is used for range queries, is also a binary tree. So most of the practically used and popular data structures, tree data structures, they are variations of binary trees. That is why we study binary tree most of the time in academics. Here are C++ and Java implementations to represent a binary tree. If you take a look at C++ implementation, we have int key, left pointer and right pointer. Similarly, in Java representation, we have int key, left and right references. Then we have constructor in both of them. The constructor initializes key with the pass parameter and initializes left and right as null. In Java, we do not need to initialize left and right as null because they are anyways initialized as null. Uninitialized member of a class are always by default initialized as null. So this is how we create a tree node. We have data or key, and then we have references or pointers of same type as we had in linked list. In linked list we had next, in singly linked list we had next, in doubly linked list we had next and previous, in tree we have left and right. In the main functions here, in both C++ and Java, I've created a sample binary tree. Let's see how does this construction work. We have first created a root node with value 10. right? We create a new node. And in this linked representation, we always dynamically allocate memory when we create tree. In Java, your objects are anyways dynamically allocated. In C++, we use new operator and we have pointers to these dynamically allocated memories. So we first create a root node and we have a reference or pointer to this node. Then we create a left child of it in the next line and we connect it with this root node. Then we create a right child of it in the third line and we connect it with this node. We make root.right or root arrow right equal to the new node. Then we create left's left child and we connect it with the left and we have its value as 40. So this is the tree which is created by main functions written in both the languages. We represent an empty tree as null. In C++, we can create a pointer root and we call it null. In Java, we create a reference and we initialize it as null. So when we have root equal to null, it means there is nothing in the tree. In this video, we have introduced binary tree. We have talked about its implementation in C++ and Java. In the next video, we will talk about tree traversals.